A company with an aging product line is investigating the launch of a new range. The business analyst has mapped out several possible scenarios given below. Scenario number 1, continue with old range producing profits declining at 10% per annum on compounding basis. Last year's profits were 600,000 ZiG from this range. Scenario 2, introduce a new range without any prior market research. If the sales are high, the annual profit is put at 90,000 ZiG with a probability of 0.7. If the profits are low, the annual profit is put at 30,000 ZiG, probability 0.3. Then scenario number 3, introduce a new range with prior market research costing 30,000 ZiG. The market research will indicate whether future sales are likely to be good or bad. If the research indicates good, then management will spend 30,000 ZiG more on capital equipment, and this will increase annual profits to 1 million. Right. On today's presentation, I will assume that this profit is 100,000 ZiG. Right. The problem with this question again, I am not seeing that there should be a full stop here. I am assuming that the full stop should be here. Let's read this again. If the research indicates good, then management will spend 30,000 ZiG more on capital equipment, and this will increase annual profits to 1 million if sales are actually high. Then, if, however, sales are actually low, the annual profits will drop to 25,000 ZiG. Again, here there should be a full stop, and we start again. Should the market research indicate good and management not spend more on promotion, then profits will be as for scenario 2. If the research indicates bad, the management will scale down their expectations to give annual profits of 50,000 ZiG when sales are actually low. However, if sales do turn out to be high, profits can, there's a full comma there, profits can only rise to 70,000 because of capacity constraints. Past history of the market research indicates the following. Actual sales, predicted sales level. If it's good and sales are high, this is the chance. If the prediction is good and the sales are low, this is the chance there. If the prediction is bad but sales are high, that is the chance. If prediction is bad and sales are low, that is the chance there. When actual sales were high, the market research company had predicted good sales levels 80% of the time, and so on. Use a time horizon of 6 years to indicate to management of the company which scenario they should adopt. Ignore time value of money. Due date 25 October 2025. So What should we do here?
Mm.
How should we approach this?
Okay. By using a decision tree.
Okay. We have got scenario 1, we have got scenario 2, we have got scenario 3.
Mm.
I just want us to approach it separately. I just want us to work out the profit that we'll get for 6 years on scenario 1. Calculate the profit that we'll get for 6 years on scenario 2. Calculate the profit that we'll get for 6 years for scenario 3. So that is the approach that I want us to follow.
Okay.
So right, for scenario 1, we are told continue with old range, producing profits declining at 10% per annum on compounding basis. Last year's profit were 600,000 ZiG from this range. What do you get about this line there?
Continue with old range, producing profits declining at 10% per annum on compounding basis. Last year profits were 600,000 from this range.
The first question that I will ask is this 600,000 the annual profit?
Yes.
Or is this 600,000 the profit for 6 years?
Or
That's
it's
the question.
saying last year's profits.
Yes, that's
So
what
it's
I'm
the
simply.
profit for 6 years.
That's what I am interpreting this. Because here,
Yes.
if you can check other profits there relative to this one, you see other profits, the annual profit for scenario 2 is 90 and 30. Do you see that?
Yes.
Other profits there, we have got 70, we have got 25, 50, sorry, we have got 25, and we have got this 1 million that I simply said I will change it to 100,000.
Mm-hmm.
So this 600 is the profit for 6 years.
Mm-hmm.
Right. If we are happy with that this 600 is the profit for 6 years, now we need to work it out. Now we are told that the profits, when we are using the old machinery, the profits are declining at 10% per annum. So every year, the profits are decreasing by 10%.
10%.
So how much was last year's profit? This is the profit for 6 years. How much was last year's profit?
Okay. If they are declining at 10%, so for year 1, it's 10% of 600,000.
Right.
And then year 2 another. So we'll be subtracting. We just find the 10% of 600,000, and we say times 6, and then we subtract it from 600,000.
All right. Let's assume here. Assume the profit for this year is 90,000, right? What will this will be this year? What will be the profit for next year? The profit for next year will be 90,000. It will decrease by 10%, multiplied by 90%. Right?
Okay.
Because next year's profit should decrease by 10% from this one. Do you see?
Yes.
So it should be this profit for last year minus 10%. So it will be 90%. So the working here will simply be 90,000 multiplied by 90,000 is 100%. So 100% less 10%. This gives us this 90%. Do you see that?
Yes. Yes.
So next year's profit will decrease by 90%, 10%. So we multiply by 90. Then the following years, which is now, let me say this will be, if this is the second year, the third year, the profit will simply be 90,000. Reduce it by 90% for this year, reduce it again by 90%. So third year's profit will be something like this. Do you see that?
Yes.
Now to simplify matters again, we will simply say, no, we don't want to write 90%. We don't want to write 90%, but we want to write 0.9 multiplied by 0.9. Are you happy with that?
Yes.
We have multiplied by 90%, 0.9 times 2. If we want to simplify, we'll simply say we don't want this. We want to say 0.9 to the power 2.
Okay.
Because 0.9 to the power 2 is the same as 0.9 times 0.9. Happy with that?
Yes.
Now let us solve this mystery here of this profit. We agreed that this profit is for 6 years, right? So if we agree that this profit is for 6 years, now we need to find the profit for last year. If this profit is for 6 years, we cannot say 600 divided by 600 per year, because these profits were decreasing, right? Right. So if these profits were decreasing, allow me to say X, that was the profit that started, because that the profit is for 6 years, plus the profit for the second year was 0.9 to the power 1 x plus 0.9 to the power 2 x multiplied by x. X is the original profit, plus 0.9 to the power 3 x multiplied by x plus 0.9 to the power 4 multiplied by x plus 0.9 to the power 5 multiplied by x equals to 600,000. So it's 6 years. This was year 1 where we started with the profit that we don't know. Second year, that profit decreased by 10%, decreased again by 10%, decreased again by 10%, by 10%, by 10%. But if we add all those profits, we get the 6 years profit of what? 600. This is the profit for year 1, profit for year 2, profit for year 3, profit for year 4, profit for year 5, profit for year 6. Happy with that?
Okay. Yes.
So when we are happy with that now, we do what is called factorization. We factor out x, because that is the profit that we started with. We need to factor that profit out. So we can simply say x, where there is x here first, we'll put a 1, because there is a hidden 1 here, plus 0.9 to the power 1 is 0.9, plus 0.9 to the power 2, plus 0.9 to the power 3, plus 0.9 to the power 4, plus 0.9 to the power 5 is equal to 600,000.
Okay.
Now let us solve everything in brackets here with our calculators. How much are we getting there if we are solving everything in our calculators there? I will simply say, let's punch our calculators. 1 plus 0.9 plus 0.9 to the power 2 plus 0.9 to the power 3 plus 0.9 to the power 4 plus 0.9 to the power 5. How much are you getting?
Okay, let me, there's a 9 to the power 4. To the power 4, how do I punch to the power 4?
I've got two
Good.
calculators here, right? To the power 4, do you see? Now I'm using a financial calculator. Let me just check here. Do you see? You are using Sharp, right? Sharp EL
Yes,
531.
yes,
All right, so 0.9 to the power, it should be YX. Do you see YX? There is a 7.
YX,
There is
yes.
yes. Click that YX.
Okay,
It will give that V that is there. Then you just punch 5.
all right.
You say
Oh,
plus.
that's what I'm supposed to do on all the 0.9 to the power 1 to the power 2.
Yes.
Okay.
Let's
I
let's
was
punch let's punch now on the I was punching on the financial calculator. Let's punch this one on this one 531. Let's say 1.
yes,
We are punching together 1 plus, right?
yes.
0.9
Uh,
to the power 1 is just, we don't put the power there, plus
mm,
0.9 to the power 2. You can click that x squared. Do you see that x2?
okay, that's the one I clicked, yes.
We click that x2, right? Then plus
Mm,
0.9 to the power 3, we click x3,
yes,
plus 0.9. Now we don't have the x4, so we click yx, then we click 4,
mm,
plus 0.9 yx5, then we say equals. How much are you getting?
I got 4.68559.
Right. Let's write that.
Okay.
68559 is equal to 600,000. Now let's divide everything by this number so that we are left with this x.
Okay.
Let me change this color and take black, right? So this will cancel each other. We'll be left with x is equal to, now let's divide that number. Right, why let's do,
600,000.
yes, 600,000 divided by 4.68559. How much are we getting?
Getting 128,000.
052 like this.
052. Yes.
So this was the profit that was there in year 1, 6 years ago.
Okay.
Do you see? 6 years ago, the profit was 128,052. But this profit was
Mhm.
decreasing by 10% all these years. Do you see?
Yes.
So what is the profit for last year? The profit for last year is this figure. Do you see that figure there? So the profit for
Yes.
last year is equal to 0.9 to the power 5 multiplied by our x. We have our x multiplied by 128,052. So let's
Okay.
whilst we are there, let's just multiply. We are there on the calculator, multiplied by 0.9 yx5. So what is the profit there?
I deleted 0.9 to
Yx
the power 5 times 128,052.
how much are you
I
getting?
got 75613.
Right, it's still the same, 75613, 75614, right? So this is the profit
Right.
for last year, right?
Yes.
Now we need to decrease this profit by 10% for 6 years, right? And
Yes.
add all those profits. So this is scenario 1. So the profit for with year 1, we start from next year because this is profit for last year. So the profit for next year will be our year 1. It will be 75614 times 0.9. It will decrease by what? 10%, right?
Mm-hmm.
75614 times 0.9 to the power 2. This is to the power 1. 75614 times 0.9 to the power 3. 75614 times 0.9 to the power 4. 75614 times 0.9 to the power 5. 75614 times 0.9 to the power 6. We have got this profit that we started with. Do you see this one?
Yes.
This is equivalent to our x there. So we can
Okay.
factorize all this. We can factorize all that.
Okay.
So let us factorize that. By factorizing that, we'll simply say total profit is equal to 75614 multiplied by, we open our brackets, we add all these 0.9s. So 0.9 to the power 1 plus 0.9 to the power 2 plus 0.9 to the power 3 plus 0.9 to the power 4 plus 0.9 to the power 5 plus 0.9 to the power 6. We can simplify individually, or we can add these and multiply one time. Do you see that?
Mm-hmm.
So let us do that. I think adding this 0.9 multiplying once will give us a more accurate answer. So let's put our calculator 0.9 plus 0.9 squared plus 0.9 cubed plus 0.9 to the power 4 plus 0.9 to the power 5 plus
Mm-hmm.
0.9 to the power 6. How much are you getting?
I got 4.21.
4.217. Don't wrap
7.
it. 31 multiplied by 75614. So what is the total profit there? Let's multiply. Multiply by 75614. So our total profit,
75614. Yes.
I'm getting 318.
Yes.
867, something like that.
Mm.
That will be the total profit for the
Yes.
next 6 years because it's decreasing. The last 6 years, the profit was 600. It will decrease. It will
Mm.
not be 600 for the next 6 years. So for the next 6 years, the profit will be what? 318.
Mm.
Done with scenario 1 and happy there?
Yes.
Let's move on to scenario 2. Scenario 2, we are told, introduce a new range without any prior market research. So we don't advertise, we don't do anything, don't promote, we just introduce a new range. If sales are high, annual profit will be 90,000 ZiG. The
Okay.
probability of the profits being high is what? 70%. If then here this the capital letter, if the profits are low, the annual profit is put at 30,000 ZiG. The probability is 0.3. So here we calculate what is called the expected what value. We calculate what is called the expected value.
Expected value.
So how do we calculate that expected value here? We will simply say if the probability expected value, we simply say if the profits are high, the probability will be 70% that we will get 90,000 as the profit. Plus, if the sales are low, the probability is 30% that our profit will be 30,000. Do you see that?
Yes.
If we have got two outcomes here. If the sales are high, the profits will be what? 90,000, right?
Yes.
If sales are low, the profit will be 30,000. But the chance, the likelihood or the chance that the sales will be high, it's 70%, 0.7. The chance that the sales will be low is 30%. So 30% chance multiplied by the profit that is low, 70% chance that the sales will be high, multiplying by the profit that will be high. So what will be our profit here? This is scenario 2. 0.7 multiplied by 90,000 plus 0.3 multiplied by 30,000. What is the profit there?
I got 72,000.
This is the annual profit, expected annual profit, expected annual profit.
Yes.
So the profit for 6 years?
That's okay, sorry, kindly hold. Sorry.
Okay. Okay. So I was explaining that the 72 is the annual profit. So we are measuring all the profits over 6 years. So the 6 years profits is what? 432,000 for the next 6 years. Are we all happy with that figure?
Yes.
So scenario 1, we have got this. Scenario 2, we simply said expected expected annual profit 0.7 times 90,000 plus 0.3 times 30,000. We got 72,000. Then total
Yes.
profit for 6 years. $72,000 times 6, we got 432,000. So as we can see, scenario 2 is better than scenario 1, right?
Yes.
So let us move on to
Oh,
scenario.
yeah.
Scenario 2 is better because we are getting 432 instead of 318. So now let us move on to scenario 3 so that we compare. Now on scenario 3, I can wrap that. Right, on scenario 3, sorry. On scenario 3, we are told, introduce a new range with prior market research costing 30,000 ZIC. The market research will indicate whether future sales are likely to be good or bad. If the research indicate good, then management will spend 30,000 ZIC more on capital equipment, and this will increase annual profits to 1 million. I simply said, I want to make this 100,000.
Okay.
If the sales are high. So if the sales are high and we are indicating the conditions are good, then our profit will be 100,000 per year. If I'm starting on this if now, if however sales are actually low, annual profits will drop to 25,000. The market research, let's deal with this. Here we are told if the market research indicate good, this is good. Do you see that good? If the market research indicate good, if sales are high, we will get a profit of 100,000. But if sales are actually low, we will get what? 25,000. Then, now let us plot that. Before we can plot that, let us calculate these conditions. We have got the condition of good that we will deal with up to this point. If the research indicate bad, so we have got another condition that is bad. So if the research says the condition is bad, but the sales can either be high or low when the condition is bad. If the condition is good, the sales can either be high or also low. Happy with that? Then if the sales are high, this is the chance, but we have the probabilities there at the back. When sales are high, we have got this 0.7. When sales are low, we have got this 0.3. Right?
Yes.
So let us deal with that. Now I want to plot now this branch first. Let me say scenario 3. We have got conditions.
Mm-hmm.
We can either have good or have bad, right?
Yes.
If the conditions are good, we can either have sales as high and also as low, right?
Yes.
If conditions are bad, we can either have sales as high and sales again as what?
As low.
As low. Now, all this what I'm doing, I am doing this condition if there is a prior, let me make that clear. If there is a prior what? Research. Do you see that? If there is a prior research,
Oh.
which means if we research, it means we spend more. Right. So
Mm-hmm.
now we need to put the figures there. That's what we need. We need to put the figures there, right?
Yes.
So let us put the figures. We have got, if the conditions are good, if the sales are high, it's 0.8 and 0.1 if low. So we come here, this is 0.8, this is 0.1. The conditions are good. If the conditions are bad, we have got 0.2 high, 0.9 low.
Mm-hmm.
So we come here,
Mm-hmm.
0.2, 0.9, right?
Mm-hmm.
Then remember, what did I say about high and low? High and low, I said we also have got other chances there, 70 and 30, right? Coming from here,
Mm-hmm.
coming from here. So
Okay.
let us use those again here. So which means here I will have happy with that?
Yes.
Right. So now let us calculate the what? The figure to put here, the figure to put here. As bad and low.
Mm-hmm.
So we are here. What is our probability of good? What is our probability of this condition good? The probability of this condition good will simply be 0.8 times 0.7 plus, because we want the expected value here, plus 0.1 times 0.3. That is good. The bad will simply be
Mm-hmm.
0.2 times that plus 0.9 times that.
All right.
Happy with that?
Yes.
Let's do that. So the good, I simply said 0.8
8.
times 0.7 plus
Mm-hmm.
0.1 times 0.3. My bet, it will be 0.2
0.2
times 0.7 plus 0.9 times 0.3. Let's find the answers there.
Okay.
0.8,
Ze-
0.8
0.8
times
times
0.7 plus 0.1 times 0.3. I get here 0.59.
5. I got 0.59.
Yes, 0.7 plus 0.9 multiplied by 0.3. I get 0.41. Obviously, the branch should add up to 1. So here I've got 0.59, 0.41.
Yes.
Happy there?
Yes.
Now we have this. So now what is our, before we put values here, we need to put our probabilities here.
Okay.
This is the branch for good. So what is the value that we should multiply by here? What is the value that we should multiply by here? The chance, the probability. What is the probability there? What is the probability there? That we should what? Multiply by. So
Okay.
right. Remember, this branch for good is is what? Is 59%, 0.59, right? So this whole branch, if we add the high and the low, we should get back to 59, right? If we add
Yes.
whatever we have on this branch and on here, we should get to 0.59. So what do we have here? We will simply say 0.7 multiplied by, 0.8 multiplied by 0.7 divided by 0.59. So what we will have here, it will be, I'll round off here. It will be 0.949. I said this multiplied by that divided by that, because these two branches, they should add up to 50, they constitute 59% of this probability between good and bad. Then I will simply say again here, 0.1 times 0.3, 0.1 times 0.3 divided by 0.59. So here I will get 0.051, like that.
Okay.
So if I add these, I will get 1. But they are constituting that 59%. So I'll come to the second one here again. I'll say 0.2 multiplied by 0.7. Now you know we divide by this. Divide by
yes.
0.41. So here I will put 0.341. Again, these two branches, they should add up to 1. So now I'll come to the bottom one. 0.9 times 0.3 divided by 0.41. So I'll get here 0.659. I'm rounding off there. Happy with those figures? If we add this and this, we get 1. If we add that and that, we also get 1. So that is, so those are my trees there. Now I need to put the values now. Now I need to put the values there to multiply by. We're told introduce a new range with prior market research costing 30,000. The market research will indicate whether future sales are likely to be good or bad. If the research indicate good, then management will spend 30,000 more on capital equipment, and this will increase annual profits to 1 million. I simply said I will put 100,000. You forgive me there. So
Okay.
if the conditions are good and the sales are high, so here we've got 100,000.
Mm-hmm.
I'm starting now here. If, however, sales are actually low, the annual profit will drop to 25,000. Do you see 25,000?
Mm-hmm.
So the conditions are good, but the sales are low. So here we have got 25. We have got 25,000. Happy with that?
Yes.
Now let's move on. Should the market research indicate good and management not spend? Right, I'll come back to this one. Let me clear off. I'll come back to that line. I want to finish first something else. Let's start here. If the research indicate bad, the management will scale down the expectations to give an annual profit of 50,000 ZiG. If it's bad, they will scale down, and when sales are actually low. So here we have got bad and low sales. Do you see that? Bad and low
Yes.
sales, the profit are 50. Bad and low sales, profit is 50. Bad, this one, low sales, profit is 50.
50. All right.
Then we move again. However, if sales do tend to be high, sales are now high, there is a comma there, profit can only rise to 70. So if profits are high, if sales are high, but the situation is still bad, but if sales are high,
Okay.
the profits are 70,000. Because here, let's go up. From here, where I'm putting there, that is where the bad is starting. If research indicate bad and the sales are what? And when the sales are low, the profit will be 50. However, if sales tend to be high, but the condition is still bad, do you see? If sales tend to be high, but the condition is still bad, the profit will be 70.
All right.
So we have filled our what? Our tree there. So now we need the expected value. So we'll multiply this because we add branches. Remember, we add branches because this, if we add that plus that, we get 1. So we simply say 0,949 times 100 plus 0,5051 times 25. When we get the answer to this one, we need to multiply by 59. Then we say 0,341 multiplied by this plus, because we add these two branches, because this 0,341 plus 0,651 gives us 1. So we say that multiplied by 70 plus 0,69 multiplied by 50. We add these two, then we multiply by 41. So the answer that we get from here multiplied by 59, we will add to the answer that we will get here multiplied by 41. Happy with that?
Yes.
So let us multiply now down here. We have got the good It's 0,949 times 100 plus 0,051 times 25.
Yes.
What is the answer do we get?
0.
0.949 times 100,000 plus 0.051 times 25,000. I am getting 96175.
Times 25,000. Yes, 96175.
Then now let's work out the bottom answer one. 0,341 times 70,000 plus 0.659 times 50,000. Point 341 times 70,000 plus 0.659 times 50,000. I am getting 56,820.
Yes, that's what I got.
Now we need to weight these. Here is 59%, here is 49% to get the answer here when we do invest. So the answer there, annual expected profit will be 0.59, that is good, multiplied by 96,175 plus the bet is 0.41 multiplied by 56,820. 0.59 multiplied by 96,175 plus 0.41 multiplied by 56,820. So I will get 8,039.45. Then I need to total profit, I need to multiply by 6
Okay.
for 6 years. Times 6. So now my profit will be 480,237.
Okay.
Now I am comparing this 480,237 with the 432 with the 318. So the 480 is better, right?
Yes.
Now let's move on to the last one, then we finish this question. Right. We now want to read from here. We want to read from here. Should the market research indicate good and management not spend more on promotion, then profits will be as for scenario 2. Do you see that? Here we're simply saying we assumed prior market research and the company the management spend. But if they don't spend, the profits will be 90 and 30, right? If they don't spend, the profit will be 90 and 30. So where is that 90 and 30? Here we are simply saying The research is indicating good, right?
Yes.
Research is indicating good, but the profits now, we now take 90 and 30. So we come to our graph here. This is our good, right?
Yes.
But here we're spending the 30,000. But now we are told if we do not spend the 30,000, we
Mm-hmm.
revert to profits for scenario 2. The profit for scenario 2, when the sales were high, the profit here was 90. When the sales were low, the profit here was 30. Do you remember that?
Okay. Yes.
So now we substitute this 25 by 30, substitute this 100 by 30. That's the only difference.
All right.
So where we calculated our good, we need to calculate our good again. But substituting this 100 by 90, substituting this 25 by 30. So let us calculate our
Okay.
good again. Here now is no spending. We are not spending on what? On 30,000 capex. So our good will be 0.949 times 90,000 plus 0.051 times 30,000. Let's calculate that.
Okay.
0.949 times 90,000 plus 0.051 times 30,000. I will get 86,940, right?
Mm-hmm.
So I will perform again. The bed will not change because I was only given good. So I will re-perform this calculation again. So I will simply say annual expected profit (0.59). The good, now I've got a new figure. Now my new figure is 86. 86,940 plus the bed remains the same. The bed is still this one. I have replaced this 96 by the newer one. So the bed is still 0.41 times 56,820. So let me
Okay.
0.59 times 86940 plus 0.41 times 56820. I am getting 74590.8. Then total for 6 years, 74590.8 times 6. I am getting multiplied by 6 from there. I am getting 447,545. So what is my advice here? I will simply say the profit that is more is this one.
Yes.
So I will simply say the management should what? Go with market research and also spend more on capital equipment.
Okay.